students. So today I'm going to perform the new experiment, and the name of the experiment is ASK modulation and demodulation. Okay, so ASK is basically amplitude shift keying. Okay, so it is basically the part of digital communication. So basically ASK is a type of modulation where the digital signal is represented as a change in amplitude. Okay, so to carry out ASK we require a carrier signal and a binary sequence signal as an input. Okay, so ASK is also known as on-off keying. So why this is called on-off keying? Just look at this waveform. Here you can see it that this one is the our digital signal, and this one, the second waveform, is the carrier one. Okay, so in the ASK, what basically happens in ASK, the data is transmitted only for high bit. Okay, high bit means bit 1. Okay, and for bit 0 we are not going to get any output. Okay, so since bit 1 and bit 0 is basically on and off only. Okay, so that's why we are calling ASK as on off keying. Okay, that means that it is on for every high bit and it is off for every low bit. Here you can see that at bit 1 or logic high, it is transmitted with carrier frequency. Okay, and bit 0, it is transmitted with no carrier. So basically we are getting here no output in the ASK. This third waveform is for ASK. Okay, so basically this first waveform is digital input signal, that is data bit. These things I have written here. Okay, so how we proceed in this part? Actually for ASK modulation we just need an transistor only. Okay, so when we are going to use the transistor, okay, we are going to provide our digital signal. This one is the circuit for this ASK modulation and demodulation. Okay, so at the base part we are going to provide our digital signal. Okay, and at the collector we are going to provide our carrier signal. Okay, so this transistor is basically used as a switch here. Okay, so it closes when input signal value voltage is 1 and shorts the output, and when it shorts the output, signal travels through the emitter. Okay, and when the input voltage is 0, then the switch opens and the carrier signal is directly connected to the output. Okay, so this is basically the ASK modulation part, and in the demodulation part we are going to have three different parts here. Just see here, firstly we are going to rectify the signal, then we are going to use a low pass filter, and then a comparator. Okay, so here at this part we are going to get our modulation part. Okay, here now firstly just see, we have used a diode here. Okay, so diode here we have used as our rectifier circuit here for the whole part, and then we are going to use the LPF. Okay, that is low pass filter. Okay, so this capacitor and this resistor is going to provide us a low pass filter, and then we are going to use an op-amp as a comparator. Okay, this op-amp we are going to use as comparator. Okay, then afterwards also, after comparator also, if we are getting ripples in the signal, okay, then we are going to use two Zener diodes. Okay, to remove the ripples. Okay, in many cases we are not getting much ripple, so that in the theory part we are not going to include that thing. Okay, but in the experiment, yes, we are getting some ripple, so to get a very good signal we are using our Zener diode. Okay, so this is basically the theory part of the ASK signal. So I will just open our multisim. So just see here, this is the circuit for ASK. This is an NPN transistor in which for the base I have given the input signal. Just see here, this is our input signal which is of 200 hertz. Okay, duty cycle is 50%, amplitude is 5 volt peak to peak, and here I am giving in the function generator 1 our 2 kilohertz of carrier signal. Okay, so it is basically a 4 volt peak to peak. Okay, and here at the emitter part, just see here, we are getting our output. Okay, so one output of this thing is connected to the oscilloscope first channel, and here for the demodulation after the Zener diode, okay, we are going to provide our demodulation output. Okay, so one output of ASK and one output of demodulation of ASK is provided to the oscilloscope. Okay, now just run the circuit and just check the output here. So just look at the output here. So this violet one line is basically the demodulation output of the signal, okay, and this red one is the modulation output. So you can see here that when bit 1 is high, we are not getting any input, but when bit is 0, we are getting the output, okay. So but in the theory we have learned that for bit 1 we should get output, and for bit 0 we should not get an output, okay. So why is this thing happening here? The reason is that basically we are feeding the output signal of the modulation part, okay, to the rectifier, then to the low pass filter, and then to the inverting pin of this op amp. So basically this invert the signal, okay. So basically this signal should have been such like that for bit 0 we should be getting no output, and for bit 1 we should be getting an output. But since we have used this op amp or the comparator inverting terminal, okay, we have used the inverting terminal as the input of this low pass filter, that's why this has inverted the whole of the signal, okay. So for better understanding I will also connect this function generator also, okay, here, so that you could understand that how actually it looks like. So I will basically delete this oscilloscope, and I will just provide a 4-channel oscilloscope here, okay, and then I will connect it here. So just take this D part to be the demodulation output, okay, and this C part I will choose our modulation output, okay. So last one is of violet and this one is of red color. So we'll choose different colors for these things. So for A part, just connect here. I will just change the color here. Suppose choose the green one, okay. Okay, choose this one for this part, that is our carrier, okay, and the last one is for this thing, okay. Here I will change again this color, suppose choose the black one, okay. So the green one is for the carrier signal, the black one is for our baseband signal, okay, and the red one is for the modulation output, and the violet one is for demodulation output. Then again run this thing. Okay, now just reverse this thing. Okay, it looks good now. Now I will show you that how actually these things look like. Okay, so just stop the simulation. Now just look at the wave here. If you'll closely look, the red one, that is our modulation output. Okay, it is showing when we are getting this black line, okay, this black line is bit high. So this black line is what? This black line is basically our the message signal, okay. So when message signal is high, okay, then we are getting the output here, okay, as our red part. Understood? So this one is basically what I am going to tell you, okay, that we have got in the 2-channel oscilloscope the output of red color when bit was 0, okay. This violet one, just look at this violet one. So this violet one and this black line is basically the same signal, okay. This black line is the input signal and this violet one is the demodulation part, okay. But both are inverted. Why both are inverted? Because we have used the op amp in an inverting configuration, okay. So we are getting the output as a violet line only when we are getting this red signal, okay, that is our modulation output, okay. So this one is bit 0 only, okay. So the reason is that this op amp is used as an inverter. That's the reason that both the signal, the input and the output signal, the baseband signal and the output of demodulation signal are inverted, okay. And we are getting the ASK part when bit high is present in the input and bit 0 is present in the output, okay. So I hope you have understood that what's the reason that both of the signals are inverted and why we are getting the ASK output when the output of demodulation is bit 0. Okay, so this one basically the whole part of this ASK modulation and demodulation part. I hope you have understood that how to perform this experiment. Thank you for watching.